Hola, buenos días. En primer lugar, me gustaría presentarme.
Hello, first and foremost, I wanted to introduce myself. My name is Claudia Zarte. I'm a senior scientist at Repsol Technology Lab as a responsible person for low CO2 emission fuels. In today's session, I'm going to speak about the net zero emission fuels as a new alternative to decarbonization in transportation. As you well know, Repsol is transforming itself towards carbon neutrality. We want to travel from the current reality in which we are based in oil and fossil fuels into a new reality when we have sustainable and carbon neutral products. When we speak about zero net emissions, we quickly think about hydrogen and electricity. If electricity itself or hydrogen are produced with renewable energies, we can actually consider that those are zero emissions. But there are alternatives to those which present several advantages versus hydrogen and electricity. It's true that we need to invest on the production of hydrogen and hydrogen itself. We need to invest in infrastructure and the vehicles, whereas for liquid fuels, we already count on the infrastructure and the vehicles themselves. It's true that we'll have to invest on generating that energy. We do have biofuels, which are currently incorporated in any fuels that we can buy on the market. The more usual ones is the first generation biofuels. Those biofuels can actually reduce the carbon imprint up to 60% versus mineral oil, and they compete with oils used for food. But legislation has changed, so that is changing in general, and we have a tendency to obtain biofuels from waste. And if they are actually made using renewable energies, we can actually go up to 90% or even further of net zero emissions. We could actually get over to a negative carbon emission. Then we have synthetic oils, which are produced using CO2 and renewable energy, and they reduce 100% their carbon imprint versus fossil fuels, traditional fossil fuels. So, when we want to speak about the reduction of carbon emissions, it's important to understand what we are talking about. Electricity, if it's 100% renewable, and hydrogen, if it's 100% renewable as well. We're gonna beat CO2 in our tailpipes, in our exhaust pipes, right? So that's gonna be good. The emissions are gonna be zero. For this type of fuels, the fuels that are biofuels are going to absorb CO2, and whenever we burn those fuels, the balance is going to be neutral. If this quantity is equivalent to the other quantity, that amount to the other amount, then that's going to be good. That's going to be zero net. So the amount of CO2 in the atmosphere is going to be the same. That's very important. We are actually increasing that presence, that amount. But the good goal is actually, one good goal is actually to be emitting zero. In some processes, we can actually emit CO2, so we're speaking about close to 90% reduction. When we speak about synthetic fuels, there could be CO2 when that we could actually get from the atmosphere that we can incorporate in synthetic fuels. We're going to have CO2 emissions, but that CO2 emission has been captured before. So the balance continues to be neutral. So let's get into detail. There is CO2 absorption during the live a life, let's say, of that waste, of that biomass, and if there's the CO2 emission during combustion, there's going to be a net balance which is 0, or it can actually be, it goes from 90 to 110. How can it be 110? Well, because we can actually use biochar. Biochar can be a subproduct of the process, and we can actually use you can use it for remediation in soil management. That CO2 will be trapped in the soil, so the balance would be negative. Electricity right now can reduce up to 70% carbon using the current mix. I don't know if you've been to the previous section on hydrogen. Our goal must be to decarbonize, so we have to bear into account the whole process from the cradle to the tomb. This is the catalog that we have, the product portfolio that we want to achieve with the different technologies for CO2 capture, carbon capture, and waste use, etc. We could actually get to negative carbon imprint fuels. So the problem with carbon emissions is a global problem, so we need to have a global solution for it. We should not just stay at the stage that we are with the current legislation. When we think about exhaust pipes, we have to bear in mind the whole value chains from the manufacturing of the vehicle, the production of the fuel, the emissions at the end when that fuel has been used by the car. So we have to do some life cycle analysis, bear in mind all stages of the use of those products. This is an analysis of our own when we compare the CO2 emissions of several different technologies focused on heavy vehicles, heavy-duty vehicles, as mostly trucks, based on several official data up to 2030. So fossil fuels coming from H2, hydrogen, and renewable CO2 have the lowest emissions, the lowest greenhouse emissions. Next is going to be waste-based fuels, which are penalized or punished by the fabrication, by the generation of the energy. The most favorite ones, the most privileged ones, are electricity and hydrogen. But, you know, there's a huge electric intensity used in the manufacturing of batteries. We hope that in the medium term, that intensity will be lowered. That means that for the whole cycle, soon these technologies will be similar. So that will leave several niches for application for the different technologies at that time. If we focus on circular waste fuels, there are currently several production methods at different technological stages. There is a lipidic way where we use vegetable oils, waste oils, we hydrogen those, we hydrogen to those, and we that technology has been escalated to the industrial phase. There are several plants in Europe producing important amounts of this type of fuels. The other way, the thermochemical one or pyrolytic one, using pyrolysis and thermal treatment, we go from biomass to fuels which are very similar to the ones that we use right now. That type of plants are at smaller or earlier stage. They are at demonstrative stage, and they need to be escalated to industrial production. And then there are fermentation ways whereby we produce alcohols which can be incorporated to gasoline, and they also need to be scalable. The key to the use of this type of technologies, one of the keys for that is the availability of waste. We have a variety of organic waste that can be employed for the production of this kind of fuel, such as waste oils, such as solid recycle fuel from waste, the organic fraction of RSU, and the biomass. It is true that these resources are quite limited, so we could not cover the whole demand by using them exclusively, but there are some alternatives to those, as I was saying before. These are synthetic fuels, also called e-fuels. There is a great availability to produce those, considering CO2 and water as raw materials for that. We can use renewable energies. We can obtain hydrogen from water by electrolysis, and we can actually take CO2, capturing it in industrial processes or getting it directly from the air through two different methods, as you see, RYGS or fissiotropisch. And we would treat those in a similar way as we treat raw mineral oil today, and we will obtain similar products to the one that we have now, which are totally compatible with current technologies. The advantage that we have in Spain for that type of fuels is the great potential that we have for generating renewable energy, either by solar PV production or by wind power. They're complementary. They enable us to have a quite stable supply of that type of energy. And how is this kind of fuel? I was saying that it's similar to the fuels that we have right now, but there are some differences. The quality of the fuels that can be used today is regulated by a framework, and that's not the same regulation regulating paraffinical fuels like the treated ones or the e-diesel, the synthetic diesel. Well, those are regulated by the EN 15940 regulation, and there is a higher ethane content. The lubricity features are a little bit worse because of their paraffinic nature, but they're regulated to some levels in which there are not going to be any problems for the engine to use this. Cold properties are very good, are below minus 20 degrees Celsius, and it is also a very stable product. Problems with gasoline, with diesel oil, is that it's not very stable. It gets oxidized, so it gets degraded. We could also include FAME or biodiesel to these fuels, and the sulfur content is also very low. It's similar to a diesel fuel, to a gasoline. It has a lower density than conventional diesel, so it's going to have a lower energy density, so there's going to be more volumetric consumption and a higher aromatic content. That's good because they're precursors for particles during the combustion process. So there's going to be a reduction of particles which are emitted during combustion. It's similar to conventional fuel, but they're not the same. Conventional gasoline actually makes engine joints push. If we use paraffinic fuel after using regular diesel, those joints could actually decrease in volume, and that could actually lead to some leaking. There is a lot of technical work being implemented already, and their engines today, they're actually compatible for that type of double use. So this is the legislation. It's just an outline of both norms, and that's basically all. As I was saying, one of the key points for these type of fuels are their compatibility with existing vehicles. That's one of the greatest advantages that these fuels have. As I said at the beginning, we'll have to invest on generating energy, but we do have the infrastructure already, and we do have the cars already. we have the vehicles already. We'll have to do some adjustments, but an increasing number of vehicle manufacturers indicate that their latest models are compatible with paraffinic oil. They usually indicate it by using the XTL name. That means that it's compatible to HVO and to e-diesel. That means that we'll be able to use this paraffinic fuel directly in our vehicles without any need for extra maintenance. We will have the same power, the same torque in the vehicles, and we will have no problem for using the vehicle during cold temperatures or at the start of the engine, and there's going to be a low tendency for the accumulation of deposits. It's also good for lubricants. It's compatible with the use of regular lubricants, and this has been guaranteed by a chartered, been championed by most of the vehicle manufactured in the world. Several heavy-duty vehicles or individual cars manufacturers have confirmed that their vehicles are compatible with the use of these paraffinic fuels. How does the legislation support this kind of fuels? It actually attacks, so to say, the three pillars on which or through which these CO2 emissions are being produced. First of all, it's the industry that makes the fuels. There is a carbon emission trait. There is a limitation for the emission for exploration and production of oil. If you do not abide by those limits, that means that you will have to pay some fines if you go beyond the established limits, as I say. Secondly, the energy suppliers. Those who supply the energy to the market, they must incorporate a percentage of renewable energy that is up to 9.5% this year to any fuel being used in the streets and roads. If not, they would be fined as well. And last but not least, the vehicle manufacturers, they also have some limits for carbon emissions. If they go beyond those limits, those CO2 emission limits, they would also be fined. What's the drawback of these? Well, the fact is that these legislations should be intertwined so that we could get to a final CO2 reduction goal that is actually interlinked, but legislations are separate, unfortunately. How does the legislation support this type of fuels? Well, for heavy-duty vehicles, heavy vehicles, there is a reduction. Thereby, there is a reduction that would like to actually would bear into account the whole CO2 emission cycle, and that the carbon imprint associated to this type of fuels is included in the legislation. Currently, this piece of legislation is being revised, and hopefully by 2023 at the latest, it will be newly drafted. New legislations recognize these type of fuels in some other places. For vans and cars, they actually bear into account the exhaust pipe emissions, carbon emissions, and they consider that we can consider clean vehicles those who use electricity, hydrogen, or pure biofuels, thereby having close to 100% reduction of carbon emissions. In order to abide by the carbon emission goals in Spain, the integrated National Plan for Energy and Climate 2021-2030 considered that this must be used. And they propose special measures for the use of this type of fuels by which or whereby they could have a special tax management. Other than PNIE, the Network 2, RED DOS, also specifies that we can have special exemptions for these fuels. The case of Sweden is one that considered a special tax reduction for this type of fuels, thereby fostering the use of this type of fuels and therefore the carbon emissions in that market. I'd like to speak to you about a pilot plan that we have for the past 4 months. We've used this type of fuels, HVO, in a fleet of buses, collaborating with ALSA. Both Repsol and ALSA have committed for the energy transition and the decarbonization of our environment, and we're doing our best to lower the emissions both on the fuel area and on the final application, which is the vehicles, the buses in this case. So this consisted of a pilot plan which has finished, barely finished. It took place between June and September 2021. We supplied 120 square meters of HVO from Repsol Technology Lab. 12 buses, 12 ALSA buses participated in that. And during the pilot project, we prevented the emission of 300 tons of CO2. We did some close monitoring of the whole cycle of the fuel, stocking, production, stocking, and use. And we also did a comparative study of pollutant emissions in real driving conditions, working with HVO and conventional diesel fuel. We did this study in collaboration with the University of Castilla-La Mancha, which is a neutral entity and has a lot of experience doing this kind of work. As I was saying, the quality of the product has been internally and externally monitored and assessed, counting on the work of independent labs, such as the Intertex one. We verified that the quality abode by the norm we're speaking about, and we see that we have some good features here regarding cetane. The cetane number of conventional diesel is 51, whereas for this HVO, we have cetane numbers above 70, so that's quite good. Density, energy density is a little bit lower than conventional diesel. It's usually 825 per square meter. So it's a little bit lower. Aromatic content is a lot lower, and we have exceptional cold temperature properties. So will not obstruct filters if it's not below minus 25 degrees Celsius. We've been monitoring also the carbon emissions. The final goal of this program is to reduce carbon emissions, right? So we have used the ISEC. It's an international certification process. It's recognized by the RED, by the network in Europe, in the European Union. We control the different points associated, the production and the emission points, and we control all of the cycle. We control the generation, the transportation, and the use of the fuel. We have been accredited. We have been authorized at Repsol Technology Lab to do that. So we could actually certify that we have only emitted 14 grams by megajoule 14 grams of CO2 by megajoule. So we've reduced 84.6% the emissions in comparison with mineral diesel use. Regarding the test and essays that we've been doing with the University of Castilla-La Mancha, as I was saying before, those have been real drive testing conditions using one of the vehicles that have participated in the pilot plant. We've been measuring for 3 days using conventional diesel fuel and HVO fuel. The vehicle was completely instrumentalized in order to monitor those conditions. And obviously, we put some weight on the vehicle in order to abide by the test regulations as well. So the result is that there are no significant differences between the consumption or the carbon emissions between one type or the other type. You see, the green part is HVO, or the conventional diesel is actually the white stripes there. So they're equivalent. And for carbon monoxide and non-burned hydrocarbons, that's exactly the same. So for those polluting emissions, there's, again, no significant difference between both fuels. NOx emissions, on particulate emissions, same thing here. We do not find any significant difference. So we can safely say that both fuels behave in a very similar way. What are the conclusions then for this pilot project? Well, the conclusion is the one we were looking for. Both fuels behave in a very similar way. HVO and conventional fuel, conventional diesel, behave in a very similar way. So operation was very similar. For the management, stocking, and use of the fuels, the driving of the vehicles have been similar. ALSA has certified that. They have detected absolutely no incidents regarding that. And these tests have been monitored by the University of Castilla-La Mancha, and they have certified that there is no significant difference either in the polluting emissions or the CO2 emissions. So we've substituted a mineral oil by a 100% sustainable or renewable fuel, and the result is that nothing has varied except for the reduction of over 80% of CO2 emission, which was the original goal of this project. And last but not least, I'll conclude my speech here. Alejandro Cavero, my colleague from the commercial area, is gonna be here with me in order to answer all of your questions and comments. Thank you very much.
No sé si no hay preguntas.
Maybe there are no questions. Or everything's clear.
Bueno, pues si no hay preguntas.
Well, if we have no questions, and maybe if you have questions later, I'll be around all day and you can ask me anything. Thank you very much.